Hey Matthew.
Hey Zach, good evening. I hope you are well, and
Yeah.
I hope I can keep you with the lesson the whole time. It's very late for doing math.
Yeah, it's all right. I just came back from some tennis, so got like my second wind for the night.
Oh, cool. Are you doing any tennis programs or just
Um,
personal stuff? What are you doing?
I just go to the like racket club and do their like clinic type thing, and then hopefully next year I'll make it to the school team.
Cool. Do you do any racquetball or just tennis?
I've never actually played racquetball, but it seems a little interesting, so I might need
Yeah,
to try that out. You do
cool.
either?
I've done both. I really love racquetball. I
That's the one
might
with
play
like
in the tournament that's
the
coming up
really
there.
smaller paddle, right?
The really small one's pickleball, which is kind of
Right.
like I hate saying it's kind of
Ping
the
pong
old
thing.
man old man sport.
I love that sport. You don't have to
Okay.
move your feet.
You don't have to be very fit to play pickleball, but racquetball and tennis, you really move around quite a bit.
Yeah.
Well, that's great. I was the reason I was asking is I have a friend. They're actually they're doing there's a place on Fort Lowell where they have that park with
Oh yeah, and it's like some
they got a tennis academy
um
there. I thought maybe that was it, but
yeah. I used to actually I don't know, I used to hit around there. I never actually did the clinics or
yeah,
anything.
they resurfaced all the courts there, so they're really
Oh
nice
yeah,
now.
it's nicer than the racket club.
Yeah,
It's like filling in it
I
when with
know.
the
Fucking
concrete and stuff. It's pretty nasty.
yeah. All right. Well, I don't want to take up too much of your lesson time here. Let's jump into whatever it is you want to work on. I see you sent over some stuff today. Solve each system.
Hmm.
Okay.
Basically what I think I need to work on is so we're gonna have a test on Monday, which is gonna be about it's gonna have the quadratic formula on it, which I'm probably the most confident on. Is that how to
Okay.
graph those things once you get those, which is something I need just a little bit of work on, I think. And then there's the subtraction type method and
Yes.
multiplication slash addition, whatever it's called.
Okay. So do you want us? Well, what I propose is doing well. So you mentioned the subtraction method. Sometimes that's really unclear for students, like when to use, like basically like, well, when do I use each method? And
Yeah.
uh, and maybe I can help to clear that up. So having said all that, though, like, do you need to get through these problems that are on this worksheet, or can I grab other problems if you?
You can just do whatever you think would be best. Those are just some problems that I had today that I just did on another piece of paper.
Okay, let me try to explain what you're looking for when you're adding and subtracting systems. And I actually remember us doing this a while back. It's okay if you don't remember doing that, but let me,
Yeah, I kind of like all of it's just like a little bit familiar.
yeah, let me grab it here. Um,
Actually, I should have checked this before, but I think she might actually have a document that. All right, never mind. Forget that.
okay, so there are. I'm gonna share my screen here. The first type of elimination, not like everything we're doing today, is actually called elimination, but there's like different types of elimination.
Hmm.
So let me share my screen here. Sorry, we're not actually getting the right button push here. Okay, so the first like elimination, there's actually like what I actually consider there to be more than one type. So the first type is where you just add the equations. The second type is subtract. The third is where you multiply one equation and then
Uh-huh.
add. Okay, and then we'll keep going here. So when you what you need to be able to do those recognize, well, when do I add, when do I subtract, when do I do this
So
other?
there's like a preferred way to do an equation.
A system, yes, this is a system.
Okay, that makes a lot more sense
It's
now.
very analogous to like we were talking about, like when do you use a quadratic formula, when do you factor, when do you complete the square. There's like times when it's like you look for the preferred method. So the preferred method here is to add, and the reason it's preferred is that one of the variables is opposite in sign from each other.
Uh-huh.
Do you see how minus 4y and plus 4y are opposite in sign, and they're
Yeah, so
exactly the same?
then,
That's why you add. That
okay.
is absolutely why you add. So this becomes 14x equals minus 28.
And then would that just be no solution?
No, no, you divide by 14.
Okay, I don't even.
That's okay.
Oh man. All right. Okay, that one makes sense. I don't know what was
Okay.
up with me for that one. So
Okay.
then
Now we know that x is
-2.
negative 2. You go back to one equation or the other to find y. It does not matter, but you might like one equation better than the other. In this
So
case, I
like the
wouldn't.
top one probably.
It You could go either way on this one. Like I'm not sure that there's like a definite preferred path here.
Uh-huh.
So when I was writing some software to generate these, we actually had some internal discussions about how to like pick the one that students would solve, and it was actually very difficult to come up with rules
Oh
for them.
really? That's interesting.
Sometimes there are clear decision making rules, and other times there's not. So we're going to add 6 to both sides, and that
And
gives you minus 4y equals minus 44.
and then y equals 11.
Yes.
So then for graphing that is the part that kind of confuses me. So it's like you have x equals what was that? Positive.
Well, these are not meant for graphing. So if we're going to do graphing,
Oh,
let's go to your worksheet and let me grab some, although these aren't very good. But they're better than mine. They're better than mine. So I guess we can.
all right.
Ooh. So your instructor really wanted you to graph these?
I don't think these ones in specific. I think it was more the quadratic formula. Now that I actually think about that. Um,
Okay.
I
Let
do have,
me.
okay, wait, no, she does want me to graph it, it looks like. Do you want me to send another picture, one more document?
Yeah, these that I'm pulling up right now are designed to be solved with elimination, not graphing, and they're
All
hard
right,
to
or
graph.
they're more like okay, my bad. This one's more like, it's just simple as like 2x minus y equals 1 and y equals minus 3. And then like by graphing and then by substitution, 2x minus.
Yeah, so let me, if you want to,
Okay,
I'm,
that's easy.
I've got another one to pull up here that I think that we can use to solve the way you're talking about.
All right.
So let me grab, yeah, here's a good one. Okay, so this is a substitution problem, which is different than elimination.
Mm-hmm.
But this one can be easily graphed, not because it's substitution, but because it's solved for y. Do you see that?
So just get the like both of those would be a y answer, or is it just gonna be one y answer?
Well, do you want to solve it with substitution and then graph, or do you want to graph it and then solve with substitution?
Um, I think solve with substitution and then graph it just because.
Okay. All right. So this is type 1 where they're both solved for y. So you set them equal to each other because you're literally putting 3x minus 6 in for y. So it's 3x minus 6 equals minus 2x plus 9.
So then that would,
You set them equal.
so I set them equal. So then would
Yes.
I add 6 and add 2x?
Yes.
So then you'd have 5x equals 15x equals 3.
Okay. And then you can go back to either equation and
And then
find,
plug it in.
yeah. So
So
let's
then
go back
y
into the
equals 3.
first one. 3 times 3 minus 6.
9 minus 6 equals 3.
Yes. Okay, so we know that that's the intersection point. And the reason that's helpful is because when you graph it, you sometimes get bad lines. So we know that the solution is 3 comma 3.
Uh-huh.
Okay, now line 1 has a slope and a b value. This might even have been our first lesson many little bit ago for it. What is the slope and the b value of equation 1?
Um, it's gonna be 3 and okay, so 3 negatives.
Yeah.
Oh, okay, my bad. That makes more
Okay.
sense. And then
So how you
0
do
to
this? How do
b
you do this? You go to negative 6, 1, 2, 3, 4, 5, 6, and then
down.
you use your slope. You go up 3
So
over 1.
3
Up,
over 1. Okay, I
okay.
was a little bit like I kept hearing slope, but I was just like a little confused on how I put that in. So
Yeah.
that's, would I just say line 1 for that one, or like
Sure.
top row line.
Sure. I mean, it doesn't really matter. You could write it off to the side. Your instructor does not need to see all this, but
Uh-huh.
you definitely want to do that. So actually got to go up here a little
So
bit.
then, okay, wait. So then for that one, it's -2
Yes. So
and 9
you're going to go down to
over 1.
right one. Yeah. So the, so down to right one, down to right one. And again, like they have to intersect where they're supposed to, which is 3, 3.
So what's it called again if they don't intersect? Or
Well, so if they don't intersect, they're parallel lines, and
right,
that is no solution.
no solution. Okay. Parallel, no solution. 2 and 1. All right. So is the graphing technically the easy part to this?
Sure, yeah. Although I think graphing is harder than just setting them equal.
Uh-huh.
But the reason the way
Oh, and
graphing,
then the equal part shows the intercepting point.
yeah, the reason the graphing is maybe harder is when it's not a nice point.
Uh-huh.
Like let's say they intersect, you know, I don't know, in between. Yeah, then you're wondering if you did it right.
Yeah. Gets a little confusing. Okay, so that makes a lot more sense to me now.
Now this one is a very like basic
Yeah, like something
substitution
that you could have been
thing.
taught like when you're in like 5th grade.
Well, I help fifth graders. I don't know that they always have that, but let me grab another one. Let me grab another type here and see if I can show you that like what else you might see here. So let me grab another question here. Okay, so here's your system. Okay, and notice that only like the second equation is solved for y.
Uh-huh.
So the graphing is not that easy at the moment. You'd have to solve the first equation for
So
y.
would I just subtract 3x over?
You could, yeah, if you wanted to do that, then that's a good strategy. Let me just rewrite it down here. You could subtract 3x from both sides. And then it's my preference to put the x term first.
Yeah, me
Sticking that
too.
up there. And then you can bring your other equation down, y equals -2x plus
And
6.
then, okay, my question is, since it's a -2 and a +6, would I divide that by 2?
No, because they're both solved for y.
So then I make it
You
equal
set
to
them
each other.
equal.
So it's like
Yes. Yes.
-3x plus 8 equals -2x plus 6. And then that would be add 2x and subtract 8. So then that would be minus x equals -2.
Yes.
Wait, yeah, -2. And then that would be +2. 2 minuses make a positive. So then that would be the interception point, correct?
Yeah. Well, that's the x value. You still need the y. So to get the y, you take your x value and put it back into one equation or the other.
Oh, right. So then let's do the
Do the
bottom
second.
row.
Yeah.
So then that would be 4
Yep.
plus 6, which is 10.
What's negative? There's a negative there in front.
-4 plus 6 equals 2.
Yes.
And then the meeting point would be 2 and 2.
Yes.
So on the graph, you'd place it as
So let me show you how to graph this, because this I chose this one because we could solve it with substitution. And like you said, so you turn the second equation into -3x plus 8. So your first equation, you would figure out the slope and the b value. Same with the second equation. This is just scratch work, but then you'd have to find that inner, find those two lines here. So do you follow that?
yeah.
Okay, let me actually move this down a little bit. So the graphing is easier once you've solved it, because you're like, oh yeah, it's right there. The slope of that first one is -2 and the b value is 6. So you go up to the b value, down 2, down 2. And then you hit it.
And
Like that.
then, so -2 and 6, and then the other one, -3 and 8.
Yeah,
Wait, could you scroll up just a little bit,
sure.
please? So if you have, okay, so you will put in the numbers after they're all switched over, so it's like y equals.
Yes, you want to solve for y generally when you're graphing, and that's
Okay.
that's where it adds a little complexity to this.
Okay, cool. So then a graph like that has an interception point, and that would be at what was that, 2 and 2 or something like that?
Yes.
And then,
Yeah, and see, I didn't, and then you start making these big dots to kind of show that that's where they intersect. That it used to be, well, you're back in school, but you really need to get the ruler out. You gotta like make really nice lines. You gotta like, so like I had an instructor that would take your line and then they would extend it and see if it hit another point that they knew was supposed to be on it. And that's how they would grade you, because they were really like adamant that you would give them the perfect graph.
Jeez, I'm glad my
Yeah.
teacher isn't like that.
Yeah, right. It's not bad. It just, they're just hoping you can like remember how to do this.
Yeah, make sure you're really getting it right.
Yeah. Yes. Like it should confirm what you already know from the earlier part.
All right. Okay, the graphs make a lot more sense now.
Right. So do you want us to do a few more substitution problems?
Yeah, let's do
Or
it.
go back to other typed.
I think
Here.
substitution's the way to go.
Okay. Okay, so here is a new problem to think about. And it's a new form that you might see. So the first equation is in what is called standard form. And that's the ax plus by equals c. And the second equation is solved for y. Okay, and that's considered a slope intercept form. That's just review. You don't have to write that down. That's just for you to remember. So one approach is to take this y right here, y equals that, and take it and plop it into the other one.
So then, that's the multiplication, correct?
I wouldn't call it that. Elimination as a multiplication step. This is still substitution. You're substituting in back there.
So rather than subtracting the 15x, you can do that.
Well, you know what? You're onto something there. You could do it that way. So yes.
And you're doing this because it's 5y.
Well, let's solve it for y. Let's do what you suggest here. So not all of them can nicely be solved for y, but I believe this one can be. Okay.
So then.
So it's 5y equals minus 15x minus 10. And the reason this one works out is because both of the numbers here on the right are divisible by 5.
Right. So you can divide all that.
Yes. And then you can do y equals 2x plus 8. That was the second equation. Now it's not bad at all. You just set them equal.
So then by doing that, you get kind of what's above, but better.
Well, like, so this equation, so let me bring this one over because it actually produces the same result. And I'll show you that in a moment, but let's solve this system here by setting them equal.
All right. You'll get minus 3x minus 2, 2x plus 8. Then subtract 2 and subtract 2x and add positive 2, negative 2, add 2, and then you'll have minus 5x equals 10, subtract that by minus 5, x equals minus 2. And
Okay,
then,
so let me just show you, you got that down. Let me just show you that this produces the same thing.
uh,
So you get 15x plus 10x plus 40, you have to distribute in. So that's 25x plus 40 equals minus 10. Subtract 40 from both sides, 25x equals minus 50.
and then,
X equals
so
x
which
equals
way do
minus 2.
you think is, like, just you personally, what do you prefer to do, like, if you had a problem like that?
So in full disclosure, there's yet another way to solve this. The more math you take, the more you get to decide how you, like when you're playing tennis and you're working on forehand, and then someone hits your backhand, you could run around your backhand to hit your forehand, but
Uh-huh.
you could also hit your backhand.
So it's good to just, it's kind of like, it's not necessary, but it really helps if you
Yes.
can just do different strategies.
Yes. So when I
Okay.
look at the first equation, I notice that they're all divisible by 5. And I would immediately divide everything by 5 and get 3x plus y equals minus 2. And so it's kind of a combination of the first two approaches, because I can just put this right in there for y.
Uh-huh.
It produces 3x plus 2x plus 8 equals minus 2. And I would still get down to x equals minus 2.
And that would be because you're doing 5x and then negative 10x equals negative 2.
Yes. So I didn't really answer your question, but it's a really good question. It's a really important question. Which is the best approach? And the answer is it depends.
Yeah, I liked the way you answer that. That like explained it very clearly.
Good, good. Do you run around your backhand to hit your forehand, by the way, or do you go solidly backhand?
Every once in a while, depends on the shot.
Okay, all right, good to know. Good to know. Okay, so there's kind of even another type here. So we should look at this other one just to see how you might attack this problem. What we did not do though is we never actually solved for y though, but you'd put it back into this equation to solve for y.
Okay, so then if you have y equals minus 3x minus 2 in that, then you'd
Yeah, you take your x value and plop it in for y.
and then 6 minus 2y equals 4.
Yes.
And then minus 2 and 4, is that like the
That's the intersection point.
okay. And then
We could graph, but
all right.
so graphing's kind of slow for this lesson. I'm happy to do it. I'll
Yeah.
remind you of Desmos to check. Do you remember how to use that?
It's the oh right, yeah, Desmos the graphing thing.
Let me show you how to graph this one.
Okay,
And
yeah, I know how to use Desmos. My bad. I was
okay,
thinking of that thing. All right, I think I've got this to an extent, and if I rewatch the video, I'd get that down.
I'm sorry. Say that one more time. I didn't catch that.
Oh, it's all good. I think I got that down enough where like I can just like go through these notes in the video, so I'd like make that connection. But I guess maybe it would probably be worth just moving on a little bit.
Okay, so this could be a substitution problem. Okay, and the reason is that it could be a substitution problem is that you can easily solve for y in both equations. Do you see that? Like, do you see how the first equation you can subtract 2x from both sides, and you get minus y equals minus 2x plus 6. Then you divide by minus 1. So y equals 2x minus 6. And then you could do the same thing on the second equation. You add 7x to both sides, and you get y equals 7x plus 9. Okay, do you see that, right? You agree with that?
Yeah, I do.
Okay, but we would not use substitution unless the instructor said you must use substitution, because when you see equations in standard form, you generally want to go for elimination. Again, standard form is ax plus by equals c, ax plus by equals c. Basically, variables on the left, numbers on the right. When it's in standard form, you want to use elimination. And if you recall from the very beginning, I said the first type of elimination is add. Why do you add these?
You add them because it's -1 and +1.
That's right. They're opposite in sign. So that gives you minus 5x equals 15. Way less writing than all this other stuff up here.
Yeah.
So you divide by -5, divide by -5, so x equals -3. And then you go ahead and substitute that into the one equation or the other. So let's use the second equation. The reason I choose the second equation is that y is positive. In the
Yeah.
first equation, y is negative, and that means you have to maybe do something. You might forget to do something.
It's just another step you can mess up on.
Yes. But they should both work in truth. So 21 plus y equals 9. Subtract 21, so y equals -12.
So then y equals -12, x equals -3. That would be the meeting point, correct?
Yes, that's the
Okay.
intersection point.
Intersection point. So then
Now, let me, yeah, so sorry, I'm looking for another one here. Let me, because I don't know why I haven't given you one like this. I guess I don't have that many here. We've been kind of eliminating y for the most part, but you could just as easily eliminate x. And this is a good example of that. You want to eliminate x here. And you do that again by adding, because they are opposite in sign.
So then would you write -4y equals 24?
Yes. So what
And
does
then
y equal?
6.
-6. Will you solve for
And then,
x for me,
and then
please?
you insert it. So you'd probably want to do the top one since
Yep.
x is positive. And
Okay.
then that would be
Can you
x
do that? Yeah.
plus
X.
54 equals 60, x equals 6.
Wow, that was really fast. That's really good. Now, always remember it's x comma y. Sometimes good to write that so you get the right order there. Okay, so now we need to go look at when you use the subtraction method. All right, and let me grab some problems here to try to make that clear, because subtraction is another part of elimination. It's the second type of elimination that I like to show students. Okay, so notice that this is in standard form. It's in standard form. You generally use elimination. The first type of elimination is add. The second type is subtract. You should say this is not add, Matthew, because a y is the same sign and x is the same sign. That's one reason why it's not add. The reason it's subtract is because it's 1y and 1y, because they're both the same sign and they're the same number. Like these match. Do you see that?
I do.
Okay. Now the subtraction, like somehow it's like really weird, awkward for students. This is what you're doing. You're saying this line minus the line below. Like you did this a million years ago. You were like, all right, 200 minus 192, and then you give me the answer, which we know is 8.
Yeah.
Okay. So what some students do, and this is where you got to kind of like decide what you think might be helpful. What some students do is they distribute the negative before doing anything.
That's how I am.
Okay. And here's what that does. You no longer are subtracting, you're adding.
Is that
now if you don't like that, we need to, so let's say you're doing this. Let's say you're doing 4 plus 5 minus 3 plus 6. okay?
9 minus
No,
9.
let's distribute it. So it's -3 minus 6, 4 plus 5. So this is 9 minus 3 minus 6. Do you see that?
Uh-huh.
It's not now subtracting this. Like this becomes plus negative negative.
Mm-hmm.
And that's what's going on here. Like this, when you distribute the negative, the minus becomes a plus.
Okay.
We'll
And
do
then
more.
that's wrong. Or
What is no, this is right.
okay.
But you're adding now.
Oh, so you're saying this is okay.
Yes, I'm saying
Okay, my bad. I thought you were saying this is like not a good thing.
no, it's like a preference. Like you got to decide what you like.
All right. Yeah, that's what I like to do. It keeps
Okay,
it more simple.
so it's 7x plus minus 6x. So that's x. Y plus minus y 0 equals -4.
And then
And then you go back to one equation or the other.
I guess
Whichever one.
probably the top one. So
Okay.
then minus 28 plus y
Yep.
equals negative 19, and then that would be positive 9.
Yes.
And then your numbers would be -4 and positive 9. That's your intersection point.
Yes.
And then,
Okay.
yeah.
All right. So do this for me. We're not focused on graphing, but I need you to I need you to attempt another subtraction problem on your own here. So take a minute or two, whatever you need, but I need this. And again, you can look back at this one if you need. It's exactly the same, just different numbers.
All right.
So take a look and let me know.
All right. I got it.
All right, what's your final answer for x and y?
-4 and -9. -4 for x, -9 for y.
Okay, now I have the answers, but here's how I check them. We actually substitute the numbers into both equations and make sure that they both work. So do you see how I put -4 in for x and -9 in for y?
Yeah.
So this becomes -12 plus -36. Does that equal -48? Yes. But we also have to check it for the other one.
So then would I
-7 times -4.
Oh, okay.
Does that equal -8? So 28 minus 36. The answer is yes.
All right. That's a cool trick.
Yeah. So the truth is that you could probably walk out of an exam and know whether you got them all right or wrong or not if you check them, if you had time to check.
Uh-huh.
But usually you don't have time like to do all that.
So for checking like that, it's you just put in 4 and 9. Like the or the x and the
Yeah.
y.
So in every problem we did tonight, like this one, you could try them in both equations, and that would be your guarantee that you have the right answer.
That's really cool, actually. I did not know you could do that.
Yes, and some tests do actually say check. Part B is to check your answer for it to verify that it's correct. But all the ones we've looked at tonight can be done that way. Okay, so we should move on to the multiply and add problems.
Yeah, I think that's a good idea.
There's two types. The first type is where you only have to multiply one equation, not both. And maybe that's all you're doing, but okay. So notice here, they're in standard form. I keep saying that because that really is important. They're in standard form. Your elimination techniques are to add. And notice if you try to just add these, you get 5x minus or plus 7y. Do you see how none of the variables cancel when you add? And that's why you can't add. So that didn't work. If you subtract, you end up getting minus x minus 21y equals some number. So that doesn't work either. You see how neither of those methods work because even though they're opposite in sign, they're not the same number.
Mm-hmm.
I don't feel like I've convinced you. Like, let's go back and look at this. Do you see how 4 and 4y and 4y are the same sign and they're the same numbers?
Yeah.
And then in the previous problem, y and y were the same numbers, same sign.
Yeah.
But in this one where we added them, x and x, they're the opposite in sign and opposite in numbers.
Yeah.
Okay, here you don't get either. You don't get any of that. Let me get down to this one. You
Oh,
get
so you'll have to make it the same.
exactly. And this is where it's a struggle for students. Well, which one is it? Well, do you see how 14 is a
And
multiple?
7. Yeah.
Yes, so you
So you
multiply
should
the,
do it by -2 if you want to make it positive 14, right?
but you
Actually,
don't want to
forget
make it.
that because you want it to make 0.
Yes, so you use positive 2. So that produces 4x minus 14y equals minus 86. And now this boxed in system, you can just add them together.
And then you'll have just 7x equals negative 28. X equals -4.
Okay. And then you have to choose one equation or the now, like they're both bad because
Yeah.
neither of them are like nice. Let's go use the second one. 3x plus 14y equals 58. So it's 3 times -4 plus 14y equals 58. So minus 12 plus 14y equals 58. So 14y equals 70, y equals 5.
5. And then -4 and 5. And then you can check that if you want to.
Yes.
And then in order to, sorry, what's the step to graph it again? I just keep forgetting that.
You'd want to solve for y, but these are not designed, at least in my worksheets, they're not designed for that.
Okay. It's just solve for y. I'm just writing that down.
Yes, the easiest way to graph and find the solution is to solve for y.
Okay. In order to graph, easiest way is to solve for y. Okay, thank you. Because I keep asking you that every single time, so I'll just keep it written. All right. So then if you have that.
Yeah, so I've got another problem here, and I noticed that your instructor didn't do this. So if you don't like the variation on the variables, you can tell me and I'll rewrite it.
All right.
So if you don't like T and U, I can rewrite this as X and Y. You tell me, do you want to just do this as X and Y or T and U?
You can just keep it as that. I'll be fine with it.
Okay. So this again, standard form. Okay. But if you add or subtract, doesn't work. You gotta, and what you're looking for is opposite signs. Do you see how?
So would you do multiply the bottom row by 2?
Yes.
All right. So then that'd be -6t plus 4u equals -26. And then that would give you a 6t plus 5u.
Okay, now just a word of caution. I have seen and personally made this mistake many times. If you don't multiply everything by the number, you will get the wrong answer and you might get something that looks horrible. So if you made a mistake, you almost have to go back to the beginning and start fresh on these.
Okay.
So just be extra careful on that.
All right. Thank you.
Yeah, so when you add these up, you get 9u equals 63.
U equals 7.
Okay, and then
And then
doesn't
you can implant that probably into the just first one.
Yeah, I also would recommend going back to one of the originals, not going back to like the modified ones because you can propagate errors.
Yeah, just a little area for mistake.
And one of the things I've noticed that I really like what you're doing is like, you're not, at least I don't think you're writing this. You're actually multiplying as you go, which is really good. Just saves time when you do that.
I don't know. Yeah, I used to do when I was for like 8 years or something like that. I did Kumon,
Yes.
and they got like that into my brain pretty well.
Yeah,
So
that's a test prep strategy is you don't write it down, you just do it because it
yeah,
saves time.
I feel like the hard. It's like I solve it like 10 seconds before I can get it all written, kind of.
Yes.
And then so U equals 7, T equals 9. Those are the interception points. And then would it be UT first or T
So
or TU?
it's generally in alphabetical order. And so if you need to
Okay.
say your
Oh, right. Yeah.
ABCs, you can,
Yeah.
but keep in mind, like an instructor could put them in the wrong order. I mean, they could do Y and then X, like
That's
that,
true. All
but
right.
generally it's in alphabetical order.
Just something to be aware of.
Generally.
Yeah. Oh man. All right. So then I guess
All right,
boom.
so let me give you one more to solve on your own here.
All right.
Of this type, I guess. Yeah, you'll do this real quick. Just do this real quick, and then we'll look at the last type together that you could see. So take a look at this one.
All right. And I'll just do this one on my own, I guess.
Yes, give that a try, please.
All right. Am I allowed to use my calculator for like one part of this?
Why don't you tell me what you need help with? Yeah, you can, but is
All
it?
right.
Oh,
It's the like minus 13x equals 143. Would that be like 11?
well,
Or well, minus 11?
yeah, go ahead and use your calculator. I didn't think the numbers got that big.
No, it's all right. I don't know. Once it gets past like 111, I'm just like, oops.
Yeah, the answer for
Oh, it's all right. I don't need the answer. I just can use the calculator.
yeah, it is 2-digit answer. So yeah, you might need it.
All right. 3 divided. Okay, it is 11. All right. Minus 11. And then okay. It's like I kind of got it, I guess. So
Did you get Y is
x
13?
equals negative 11, and then y. I didn't actually really get y,
Okay,
but
let me work this out for you then. So did you multiply the second equation by 3?
by yeah, I did.
Okay, so
Obviously.
it becomes minus 9x plus 3y equals minus 60. And this is another thing, you don't want to keep, you really do want to rewrite. I know it's extra to do this,
Uh-huh.
but you're
It helps.
refocusing on this down here, not the one above. So it becomes minus 13x equals minus 143, x equals 11. Now, which equation to use? I'd probably use the second equation. So
Yeah, I
minus
think I
3.
made the mistake of using the top one instead.
Yeah, and because y is kind of already solved for here.
Yeah.
Okay, so you get y equals 13 when you do that.
Oh, and then my mistake was I looked at not the original, I looked at the other.
Yeah.
Okay. All right, yeah, that's a good learning thing. All right. Yeah,
All
this
right.
isn't really super tricky, thankfully.
So the next type you're gonna see, and there actually are a couple on your worksheet there. That they're at the bottom. So I don't know what this, but they're the kind of what I consider the true elimination. Okay, and when I mean true elimination, I mean you can't add, you can't subtract, you don't get to just multiply one, you have to multiply both equations by a number.
So,
And what,
number.
yeah, so like I'm gonna just show you this. When you, if you look at K, E, F, K, and L, they all are this type on your thing. But you multiply the first equation by 2 and the second equation by 3, because I'm going to eliminate the first variable. So minus 6y plus 4z equals minus 46. 6y plus 21z equals minus 54.
And then that would be 25z equals 100, or well, negative 100, z equals
Yes.
minus 4. And then you should insert that probably into the second row.
Sure.
And
so
then
2y plus 7 times minus 4 equals minus 18. 2y minus 28 equals
minus 46, and then y equals
you're adding
negative
20.
23. Shoot.
Yeah.
Almost got it.
Almost got it. All right. So, you know, they're not great. Frankly, they're the toughest. It didn't seem like your instructor was emphasizing that. Let me grab one from your sheet and we'll run through it, and that'll probably take us to the end of our lesson time for today.
All right.
So again, notice it's in standard form, not letter variables on the left, numbers on the right. But if you try to add or you try to subtract, none of them go away. None of these numbers are multiples of each other. That's why you can't just multiply them. So here you actually have to multiply both. And you look for the ones that are opposite in sign, if there are any. So see how minus 3 and 2 are opposite in sign.
Oh yeah, that makes more sense too. It saves you more steps.
Yes. So the first one is 14x minus 6y equals minus 10. The second one is 9x plus 6y equals 33.
So then that would be 23x equals 22. And then that's just, no, 23.
Yes.
Okay, and then x equals minus 1. And then you can just, that one really could insert to anything really, but 6y.
Yeah, I'm gonna go the first one because again, don't go to this one. Do not go to this one. Go back to the original.
Right, my bad.
Yes,
I'm writing
it's such a
easy.
You will at some point be like, oh yeah, when you're solving problems, you always go back to like what you know for sure works, and you like okay, this works and this works. Like that's why you go back to the original, because you know it works. And so you add 3, 2y equals 14, and y equals 7. All right. So I do have a substitution and an elimination worksheet on my website. I think they're under Algebra 2. I know you're in Algebra 1, but I think that's where I ended up sticking them under.
All right. Thank you.
I'll send you the links to them. There's a lot there. You don't have, I mean, you don't want to, I mean, you'll fall asleep if you try to do all, but if you need more practice, you just go ahead and print one or the other and just, you know, see what you can do on your own.
All right. Thank you.
All right, Zach, thanks so much. That does take us to the end of our lesson for tonight.
Right, so awesome. Yeah, that's helped a lot. Like even the first 10 minutes taught me like a week's worth of stuff.
Glad to hear. Have a great night.
All right, you too, Matthew. See you.